Hello viewers, in today's session we are going to discuss another very important and conceptual problem from derivatives involving the absolute value function, which is also known as modulus function, right? So in this class we are again going to solve one important problem related to derivatives. So here we have a function f of x, which is given as a mod of secant 3x, and we have to find the value of this expression, that is e raised to greatest integer of f prime of x at x is equal to 5 pi by 12, right? So here we are given a function that is a mod function, the mod function of a trigonometric function, and then we have to find the derivative of this function at this point 5 pi by 12, and then with the help of the value of the derivative at this point, we'll calculate the value of e raised to greatest integer of f prime of x. So here we are going to use the definition of mod function and some important concepts from trigonometry. So let us start. So now let us first quickly see the sign convention of trigonometric functions in the four quadrants. So here we have the four quadrants. This is first, second, third, and fourth. So here we have 0, here we have pi by 2, here we have pi, here we have 3 pi by 2, and then we have 2 pi, right? So here we have f of x is equal to mod of 3x. Right now, see, in the first quadrant all the trigonometric functions are positive, and in the second quadrant only the sine and cosec functions are positive, and in the third quadrant only the tangent function and cotangent function, that is cot and tan function, are positive, and in the fourth quadrant only the cosine function and the secant function are positive, right? So now here we are given f of x is equal to mod of 3x. Now here let us see this term, that is 3x. Now we have to find the value of the derivative at this point, that is 5 pi by 12. So let us find out the value of 3x at this point. So we have 3 times 5 pi by 12. So this is 3 times 4, 12. So we have 5 pi by 4, that is 225 degrees, right? So we see that this angle, that is 3x, it lies in the third quadrant, right? And in the third quadrant the secant function is negative, because the tan function and cot function are positive, right? And the remaining four trigonometric functions are negative. So here this angle, that is 3x, this is our 3x, and 3x is equal to 225 degrees at this point, and this angle falls in the third quadrant, and in the third quadrant the secant function is negative, right? So 3x lies in the third quadrant, that is 3x is greater than pi, but it is less than 3 pi by 2. So the secant function is negative. Now let us quickly see the definition of mod function. Now see, a mod of p is defined as negative p when p is less than 0. So here we can also define mod p as positive p whenever p is greater than 0, and mod of p is 0 when p is 0. But here I will use only this part of the definition. So mod of p is negative p when p is less than 0. So now secant x, secant 3x is negative, that is it is less than 0 when x is 5 pi by 12. Or we can in other words we can say that 3x lies in the interval that is pi to 3 pi by 2. So mod of secant 3x is equal to negative of secant 3x when 3x belongs to the interval that is pi to 3 pi by 2. So remember here secant 3x is assumed to be p, right? So mod of p is equal to negative of p when p is less than 0. It means secant 3x is less than 0 when 3x belongs to the third quadrant, right? So now f of x is given by a negative secant of 3x. So now let us differentiate f of x with respect to x. So the derivative f prime of x is given by d by dx of negative of secant 3x, that is negative d by dx of secant 3x. Now from the standard results from derivatives, we know that the derivative of secant theta is given by secant theta tan theta. So here theta is 3x. So we have minus, then we have secant 3x, tan 3x, and by chain rule, the derivative of 3x. So the derivative of 3x is simply 3. So we have minus 3 secant 3x tan 3x. So the derivative, that is f prime of x, is given by this expression, that is minus 3 secant 3x tan 3x. So now let us write f prime of x as minus 3. Secant 3x can be written as 1 over cos 3x, and tan 3x can be written as sine 3x over cos 3x. So we have minus 3, and here we have sine 3x, and here we have cos square 3x. So this is another expression for the derivative of f of x. So now let us find out the value of the derivative at this point 5 pi by 12. So f prime of 5 pi by 12 is given by minus 3 sine. We have 3 times 5 pi by 12, taking x is equal to 5 pi by 12, and then we have cos square 3 times 5 pi by 12. So here we have minus 3 sine, this is 3 times 4, this is 3 times 4, we have sine 5 pi by 4 divided by cos square 5 pi by 4. So now we have to find the value of sine 5 pi by 4 and cosine 5 pi by 4. So let us use some trigonometry to get the values of sine 5 pi by 4 and cos 5 pi by 4. So sine 5 pi by 4 is given by sine pi plus pi by 4. So we can split 5 pi by 4 as pi plus pi by 4, and similarly here we can write pi plus pi by 4. So here we have sine pi plus say theta, and here also we have cos pi plus theta, right, where theta is given by pi by 4. So sine pi plus theta is given by a minus sine theta, and similarly cos pi plus theta is given by minus cos theta. So here we have minus sine theta is pi by 4, and here we have minus cos pi by 4. So this is minus 1 over square root of 2, and here also we have minus 1 over square root of 2, because sine pi by 4 and cos pi by 4 are equal to 1 over square root of 2. So now f prime of 5 pi by 12 is given by minus 3, and sine 5 pi by 4 is given by minus 1 over square root of 2. And here we have cos square 5 pi by 4, so we have minus 1 over square root of 2 square, right? Okay, so now this is minus time minus plus, so we have 3 by root 2, and this is minus 1 over root 2 square. So we have here a 1 over 2, right? So this is 3 over root 2 times 2, and that is 6 over root 2. So we can now write 6 over root 2, rationalizing the numerator and denominator by square root of 2. We have 6 root 2 over 2, and this is 2 times 3 6, so this is 3 root 2. So the value of the derivative of f of x at this point, that is 5 pi by 12, is given by 3 times square root of 2. So now our aim is to get the value of e raised to greatest integer of f prime of x at this point, that is 5 pi by 12. So we can now write e raised to the greatest integer of f prime of 5 pi by 12. F prime of 5 pi by 12 is 3 root 2. Now see, the value of 3 root 2 is given by 3 times. The approximate value of square root of 2 is 1.414, and if we multiply 3 and 1.414, we'll get 4.242, right? And the greatest integer of 3 root 2 is given by greatest integer of 4.242, and the greatest integer of 4.242 is 4, right? So the value of e raised to greatest integer of 3 root 2 is given by e raised to 4, right? So the value of this expression, that is e raised to greatest integer of f prime of 5 pi by 12, is equal to e raised to 4. Hello viewers, in today's session we are going to discuss another important problem from derivatives, and in this class we are going to find out the derivative of cos inverse x square using the concept of first principle, right? And here we'll see the step by step method how to arrive at the derivative of cos inverse x square. So let us start. So let us take this function cos inverse x square as y. That is, we can assume y is equal to f of x is equal to cos inverse x square, right? And from the definition of first principle, we know that the derivative of a function y with respect to x is given by this limit, that is limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x, right? So here we are using the notation delta x for h, right? And here we have the function y is equal to f of x. So the derivative, that is f prime of x, is given by this limit, and this is known as finding out the derivative of this function y using the first principle, right? So when we compute this limit, we get the derivative of y with respect to x, and here delta x is a small increment in x, and the corresponding increment in y is denoted by delta y. So delta x and delta y are the very small increment in the independent variable x, that is delta x, and delta y is the small increment in the dependent variable y. So we have y is equal to f of x is equal to cos inverse x square. So we can now write y is equal to cos inverse x square. So now we can take this cos inverse to the left hand side. So we can now write cos of y is equal to x square. So let us take this expression or this equation as equation number 1. So now let us make a small increment in x, which is delta x, and the corresponding increment in y is delta y. So we can now write cos of y plus delta y is equal to x plus delta x square. So y is now replaced by y plus delta y, and this x is replaced by x plus delta x, right? So now we have these two equations. Now let us subtract equation 1 from 2. So we have 2 minus 1, that is equal to x plus delta x square minus x square, and then we have cos of y plus delta y minus cos of y, right? Now x plus delta x square can be expanded using the identity a plus b square. So we have here x square, then we have delta x square, and then we have 2x delta x, and then we have minus x square. So this is a square plus b square plus 2ab, and here we have the difference of two cosine terms. So here we can make use of an important identity from trigonometry, that is cos of a minus cos of b is equal to minus 2 sine a plus b over 2, and here we have sine a minus b over 2, right? So we can take a as y plus delta y, a is y plus delta y, and b as y. So here we have minus 2 times sine of a plus b over 2. A is y plus delta y plus b is y. Here we have 2, then we have sine y plus delta y minus y, and here we have 2. So now here x square and x square get cancelled. So we have delta x square, then we have 2x delta x, and here we have minus 2 sine, and here we have y plus y is 2y, and here we have delta y over 2, which can be written as y plus delta y over 2. So we have sine y plus delta y over 2, and here we have sine this y and this y get cancelled, so we have delta y over 2, right? So this is our equation number 3. So now the next step is to divide both sides by delta y, right? So here we can write delta y, and here also we can write delta y, right? So what we have done, we are dividing both sides by delta y, and now let us take the limit, that is the limit delta x tends to 0 on both sides. So we have here a limit delta x tends to 0, and here we have limit delta x tends to 0, right? But here what we will do, when delta x tends to 0, then delta y also tends to 0. So it implies that when the increment, that is delta x, is tending towards 0, then the corresponding increment in y, that is delta y, also tends to 0. So here, instead of writing delta x tends to 0, we can write delta y tends to 0, because when delta x tends to 0, delta y tends to 0. So here we have the term involving delta y. So now let us further simplify both these sides. So we can now write limit delta x tends to 0, and we can take delta x common. So we have delta x plus 2x, and in the denominator we have delta y, and here we have minus this negative sign, and we can now write a limit delta y tends to 0. So first we'll write sine y plus delta y over 2. Then we can write limit delta y tends to 0, and this 2 can be taken in the denominator of delta y, right? So that we have sine of delta y over 2 divided by delta y over 2, right? So that we can convert this limit into the form that is limit theta tends to 0 sine theta over theta. So now we can write limit, and then we have delta x tends to 0, and here we have delta x plus 2x, and see this delta x can be taken to the denominator of delta y, right? So here we have delta y over delta x, and now here we have minus. Now limit delta y tends to 0 sine y plus delta y over 2 is equal to sine of y, because this delta y tends to 0, so this term is 0, and we are left with simply sine y, and the value of this limit is equal to 1, because we know that limit theta tends to 0, sine theta over theta is equal to 1. And remember, when delta y tends to 0, then delta y over 2 also tends to 0. So if we take delta y over 2 is equal to theta, then this limit reduces to limit theta tends to 0 sine theta over theta, and this limit is equal to 1. So here we have 1, so this is minus sine of y. So now we have the limit in the left hand side. So now we can write limit delta x tends to 0, delta x plus 2x, and in the denominator we can write limit delta x tends to 0, and we have delta y over delta x, right? So the distributing this limit notation to the term that is delta x plus 2x and delta y over delta x, using this theorem, that is limit x tends to a, and we have f of x over g of x, that is equal to limit x tends to a f of x divided by limit x tends to a g of x, and here we have simply minus sine y, right? Now limit delta x tends to 0, delta x plus 2x, so this term goes to 0, so we have 0 plus 2x in the numerator, and this is the notation for dy over dx. So here we can write dy over dx, because from the definition of derivative we know that dy over dx is equal to limit delta x tends to 0 delta y over delta x. So limit delta x tends to 0 delta y over delta x is given by the notation, that is the derivative dy over dx, and here we have minus sine of y, right? So here we have 2x, and in the denominator dy over dx, and this is minus sine y. So simplifying, we can take dy by dx to this side, so we have 2x minus sine y times dy over dx, and now dy over dx is equal to 2x over minus sine of y. So now this term sin y can be written as square root of 1 minus cos square y, right? Because we know that sine square theta is equal to 1 minus cos square theta, and sine theta is equal to square root of 1 minus cos square theta. So now we have 2x, here we have the negative sign, and here we have square root of 1 minus cos square y, right? Now see, initially we have assumed that y is equal to cos inverse x square. So x square is equal to cos of y. So now taking cos y is equal to x square, over here we have minus 2x divided by square root of 1 minus x square whole square. So this is minus 2x divided by square root of 1 minus x to the 4, right? So viewers, the derivative of y with respect to x is given by minus 2x divided by square root of 1 minus x to the power 4, and y was cos inverse x square. So the derivative of cos inverse x square is given by minus 2x divided by square root of 1 minus x raised to 4. So this is how by making use of the concept of first principle. So first principle means the definition of a derivative of a function. So dy by dx is given by this limit, right? And the derivative of cos inverse x square is minus 2x divided by square root of 1 minus x raised to 4. So following the same steps with minor changes, we can easily find out the derivative of sine inverse x square. And this problem is left as an exercise for all our learned viewers.